Good morning, friends. Good morning to everybody. I am Mr. Nana Mirge, and I will teach you thermodynamics. 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 Now look, thermodynamics. In this chapter, we have to learn about how thermal energy is changed. Look the word thermo. What is meant by the thermo? These words are made from two words, thermo and dynamics. So first one is a thermo. Look, thermo. Thermo regarding to heat, and dynamics. Dynamics. Dynamics to change. To change. And thermo means heat is changes during the chemical reaction. What happen in lot of chemical reaction? We have to a chemical reaction which is either endothermic and exothermic. Heat is liberated or heat is absorbed. In thermodynamics, this thermo means heat and dynamics means to change. So how you can define the heat? Heat can define the total 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 kinetic energy energy of molecule. Total kinetic energy of molecule is nothing but your heat. And dynamics, so heat and another terms is temperature. Look, heat and temperature, heat is different, temperature is different. So temperature, you can also define temperature. Temperature is defined as the total, the average. It is a average kinetic energy of molecules. Look, heat is the total kinetic energy of molecule and temperature is average kinetic energy of molecule. So here energy, and look it energy. So what is, again a question comes out to the what is meant by the energy. So energy, we can define the energy. It is energy, it is a capacity to do to do a work. Work is a different type of work, chemical work, mechanical work, or different types of work. So energy is nothing but a capacity to do a work, so that is called energy. So look, heat energy, whenever we have to deals with, particularly in thermodynamics, we have to deals with thermal energy, and thermal energy changing during the chemical reaction. What happen in when we perform any reaction, at that time energy is changed, particularly thermal energy. Thermal energy is changes, going on to change. The change is occur during the chemical reaction. So we have to be thermodynamics and reaction. There is two type of reaction. So either endothermic reaction, endothermic. So look this word, endo and thermic. So endo means inside, and therm means heat, endothermic, or we can say endoenergetic, endoenergetic reaction, endothermic reaction. Or another one is a exothermic reaction or hexo. So the word is hexo means out, taken out, means reaction. Whenever a reaction, there is a liberation of thermal energy, so we can say it is a exothermic reaction. Means two type of reaction, one is the endothermic reaction, another one is the exothermic reaction. We have to deals with here energy changes. Energy changes when a chemical reaction is occur, and chemical reaction is having two types, endothermic reaction and exothermic reaction. In endothermic reaction, there is a heat absorption of heat, and exothermic reaction, there is the liberation of heat energy. So in thermodynamics, we can say in chemical thermodynamics, particularly the word thermodynamics means heat energy changes during the chemical reaction. So we can say, or we can write like this, the heat energy, thermodynamics, the thermodynamics thermodynamics. Dynamics. The heat energy. What we can write? The heat energy. Heat energy changes. Heat energy changes during. Heat energy changes during chemical reaction. Chemical reaction. Heat energy changes during chemical reaction. And we have in thermodynamics particularly we have three topics: thermodynamics, chemical kinetics, and chemical equilibrium. So what we have to learn, you have three topics. First one is chemical thermodynamics. In thermodynamics, what we learn in thermodynamics, we have particularly learned about feasibility of chemical reaction. What we learn? Feasibility of chemical reaction. Feasibility of chemical reaction. What is meant by feasibility of chemical reaction? Look, at certain condition, a reaction is proceed. It may be physical reaction or chemical reaction. At certain condition, reaction will be proceed. At what certain reaction, what certain condition? Condition is very much important to proceed a chemical reaction. For example, we have to say, suppose ice is converted into liquid, but suppose a surrounding temperature is having 25 degrees Celsius and ice having temperature -2 degrees Celsius. At that time, after some time, the ice is converted into liquid one. So why? Because of surrounding temperature are more than the system's temperature. So it is endothermic reaction. Heat is absorbed and the ice is converted into liquid form. So feasibility of chemical reaction. The feasibility of chemical reaction can be determined by chemical thermodynamics. Look, what we can have understand, or what we have to understand in thermodynamics, a feasibility of chemical reaction can be determined by using chemical thermodynamics. Means feasibility of chemical reaction can be determined by using chemical thermodynamics. Of feasibility of reaction can be determined by chemical thermodynamics. So energy here, particularly we have to learn about the energy changes, how energy change during the chemical reaction. There is a certain objective of chemical thermodynamics. Certain objective, which one? How reaction takes place, and how much to predict the yield of product, how much product is formed. In main objective of thermodynamics, feasibility of reaction. Another one is the to determine the yield of product. To determine the yield of product, how much product is formed. Suppose we have to perform a chemical reaction in lab, so there is a certain amount of reactant and to form a product molecule or product. So this product, during the formation of product, how much reactant molecule are converted into product one. So how much energy you have to supply, or how much energy is liberated during the chemical reaction. All these things will be happen when reaction takes place. So various type of reaction. So suppose a certain amount of reactant reacted and to form certain amount of product. So how much yield you have to be obtained, which is determined by chemical thermodynamics. Then to generalize or to predict some laws, or to generalize some equation. For example, to generalize some equation. Like a phase rule. To generalize some relation. For example, phase rule and other things, other rules, and or to formulate the first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. all these things we can formulate by using chemical thermodynamics. Look what we have to learn one by one. We can you have to be remember. First one, thermodynamics. What is mean by thermodynamics? Thermodynamics, it is the word made from two words, thermo and dynamics. Thermo means regarding to heat. Heat is nothing but energy. Energy. What is mean by energy? Energy is nothing but a capacity to do a work or to perform a work. Means more is the energy, more you have to work done obtain. That means you have a tremendous amount of energy, more is the work done you have to perform. Means larger energy, larger is the work done. So energy, see, energy, it is a particular dynamics means to change, and thermo means heat energy. Heat energy, you can define the heat. How we can define the heat? Heat is nothing but the total kinetic energy of molecule. It is called heat. And another definition which is comes out the temperature. Absolute, it is a temperature which is average kinetic energy of the molecule, is nothing but temperature. It is the basic difference between heat and temperature. Heat is the total kinetic energy and temperature is the average kinetic energy of the molecules. So, and energy, it is the capacity to do work. So a reaction, which is whenever a reaction takes place, there is two types of reaction. One is endothermic reaction, another one is the exothermic reaction. In endothermic reaction, what happens? Heat is absorbed by the molecule. That is, heat is absorbed from surrounding. Heat is absorbed. In endothermic reaction, heat is absorbed. That is, we call the endoenergetic reaction. And when exothermic, exo means outside, heat is liberated during the course of reaction. During the reaction, heat is liberated. So that is called exothermic reaction. So it's all these things happen in a chemical reaction. Means the heat energy changes during the chemical reaction. That is, any reaction which takes place, the heat energy changes. Either heat energy is absorbed or either heat energy is liberated. So during this thing is happen in chemical reaction. So in thermodynamics, what we learn about the basic things, we have to learn feasibility of chemical reaction. What is meant by the feasibility of chemical reaction? Feasibility of chemical reaction, that it is a certain condition you have to provide it. You have to provide it the temperature, the number of moles, and the pressure and volume. So all variable or this certain condition you have to provide it, and you have to decide either reaction is proceed or not. Means a certain condition, and you have to decide it either reaction is proceed or not. And another thing we have to learn about thermodynamics to determine the yield of product. Means certain reaction we have to be suppose amount of reactant we have to taken and product is formed. So how much reactant you have to taken and how much product is formed. That is yield of chemical reaction we have to determine by using chemical thermodynamics. And then another one is to generalize the equation, to formulate the laws of thermodynamics, and to formulate the phase rule and other equation you have to generalize by using chemical thermodynamics. And is all about the introductory part of chemical thermodynamics. Means a thermodynamics, it is a branch of science which deals with heat energy changes during the chemical reaction. What I say, listen, thermodynamics is the branch of science which deals with thermal energy changes during the chemical reaction. Whenever a chemical reaction, there is a heat energy change occur. Means we have to deals with heat energy changes during the chemical reaction. It is called chemical thermodynamics. Chemical means reaction. Chemical reaction is occur. There is a change in thermal energy. Energy is we have to already define the energy. What is mean by energy? Energy is nothing but a capacity to do a work. So look, in this thermodynamics, particularly in 11 and 12, a question may be asked. Logical question or reasoning type question, you may be asked how define the thermodynamics, and how chemical energy is changed and how heat energy is changed during the reaction. So all these things you have to learn. Then there is a certain limitation. Another one is the limitation of thermodynamics. In short way, we can discuss about the limitation of thermodynamics. Here I can write limitation of thermodynamics. So first limitation, thermodynamics it deals with only microscopic properties of the molecule. It deals, number one, it deals with macroscopic macroscopic properties properties of matter and it does not deals it it do not deals with deals with do not deals with the microscopic properties of matter. Look, it is a very important limitation of thermodynamics. Whenever whenever there is thermodynamics, we have to deals with properties, large property, bulk material we have to study under the thermodynamics. Bulk material we have to learn under the thermodynamics. Means, for example, proton, neutron, electron. We cannot deals with thermodynamics. Thermodynamics purely a bulk material properties of matter. We have to study it. And another one, it is it deals with the feasibility of chemical reaction. What we have to another one, it deals with feasibility of reaction. It deals with feasibility of reaction, and it do not deals with rate of reaction. Look, rate or velocity does not determine by using the chemical thermodynamics. Thermodynamics do not tells the rate of chemical reaction, isn't it? Okay, thermodynamics does not deals with the rate of chemical reaction. Another limitation is it do not deals with the extent of chemical reaction. It do not deals with extent of chemical reaction. Means, the extent of reaction does not deals with by using chemical thermodynamics. Means, and where we have to deals with extent of chemical reaction, there is another topic, a chemical equilibrium. In that topic we have to deals with extent of reaction. That means, look, it does not deals with extent of reaction. Extent of reaction, where we have to deal a chemical equilibrium. And rate of chemical reaction, which deals with the chemical kinetics. There is another topic which is chemical kinetics, and that topic we have to deals with rate of reaction, isn't it? Okay, so a certain limitation. And another limitation, last limitation, it deals with only initial state and final state. It deals with initial state and final state initial state and final state of the system. Initial state and final state of the system means it does not deal with previous history of the system. Means, where the system comes from and what is the previous history of that system and what happened after the reaction. Means, it is deals with only initial state and final state. It does not deals with path of the state, which one path followed by that particular function, or path cannot be which one path is selected, which cannot be studied by under the thermodynamics. It does not deals with the path followed by that particular reaction from from one state to another state. That means it deals with only initial state and final state. only initial state. What I say, the thermodynamics can deals with only initial state and final state. In between, the path cannot be studied by the thermodynamics. Okay, isn't it is a certain one, certain, that is, you can remember all the limitation of thermodynamics and main points of thermodynamics. What is thermodynamics, and heat energy changes, how feasibility is checked by the using chemical thermodynamics, isn't it? It is an introductory part of the thermodynamics. Okay, thank you very much.